So this summer we worked at the University of Utah. Spencer Keating. This is Lexie Gardner.
We're both from Telluride High School.
So we worked with the carbon sequestration, carbon science and engineering research group at the University of Utah. So yeah.
So we worked with Dr. Brian McPherson and the Carbon Science and Engineering Research Group, and we worked on carbon sequestration, which is taking ambient carbon dioxide and storing it in underground reservoirs.
So one of our main projects was to set up a Arduino communication network, and this was used to, this was like kind of a prototype for a system that would be able to detect leaks in a carbon sequestration field. So these were just the devices we were using, communication devices, to set that up.
So our end goal was to develop a remote carbon dioxide sensor network that was capable of detecting leaks in a carbon sequestration field, and then it would be able to transmit this data to a hub and then analyze it for CO2 leak detection. So ideally, it would be set up in a grid system like this, and then the data would relay through a bunch of Arduinos until it got back to a hub, so it was entirely hands-off in terms of like researchers.
So at first, we were just using temperature sensors because those are a lot cheaper to buy than than carbon sensors. And we just wanted to set up the communication network and try to make like a proof of concept. So this was like the central hub. This is how the data would come in, and that's the temperature in Celsius and the whatever sensor it is. So we had to figure out ways of getting that into like a usable format, because if you're getting like one data point a second, it's going to build up very quickly. So you want to be able to get that into a usable format.
So then what we did next is we added the XBs to the Arduino so that they could communicate wirelessly. And then we tested them outside the office, so we had places around the office that we put them, and then we moved them around to test out their range. And we ended up getting up to 1,200 feet of communication distance between them as long as we had line of sight. But then after that, the data came in a little weird, as you can see in the picture right here.
So our second task that we had was to develop a method to test the accuracy of a measurement strategy for CO2 leaving a flue. So we set up these buckets, and we'd basically run CO2 underneath them, and there'd be a fan, and then we'd measure wind velocity and CO2 concentration data at the top, and then we'd use an equation to compare this to how much CO2 left the tank.
So to begin this process, we first found the mass flux of carbon dioxide, which is just the amount of carbon dioxide leaving a certain area over time. And so to do this, we just used a compressed gas cylinder with carbon dioxide in it and put it on a scale, and then gathered data from the scale. And then it ended up being a linear relationship, which is what we were hoping for.
So this was some of the equipment we used. The Picaro right there was a really expensive machine. It was like over $10,000. So the graduates were definitely very careful with it. Like we had to shut it down before we'd wheel it around in its cart. But this thing could measure CO2 to the part per million. So it was very cool. It was a little more accurate than we really needed for the experiment, but it was definitely it was really fun to work with. There I am taking some measurements around the bucket. Those would last like half an hour, so that was good.
And then when we weren't working on either of those two projects, we actually spent some time in the rock mechanics lab. So we were looking at the permeability and porosity of different rocks, and that is just how much fluid can flow through a rock. And so this was helpful for us because that can tell you how much CO2 you can put into the rocks before they will fracture. And if you fracture a rock, then all the CO2 that you just pumped into the ground will come right back out. So this was really helpful in like the beginning process of our Arduino project.
So outside the internship, I was always climbing some mountains or something. So there's a picture of that.
And I had a really amazing host family. They took me all around Salt Lake City. We went to the botanical gardens. We went up to Park City a couple times, and I attended a couple conferences and went to some festivals with them.
So the advice to future pinterns is just apply. Pretty obvious, but that's definitely a good first step. If you do get an internship, I'd recommend asking a lot of questions to your mentors and stuff, because I mean they're like PhD candidates, doctorates. They're wanting to learn, explain things to you. So they're super passionate about what they do. And take some photos, because we did not take enough.
We just wanted to say a huge thank you to everyone who made this possible, especially to Dr. Brian McPherson for welcoming us into his lab.
Awesome.